Hello, my name is Pete Knapp and my PhD project is with Imperial College London, and it's to investigate the charge distribution of indoor aerosols. It's in partnership with Dyson. The reason I became interested in air quality was after living in Beijing for 3 years, where an unhealthy reading like this was quite common. However, these readings were always the outdoor levels, and it's assumed by many that being indoors protects you from this, but this wasn't the case. I worked in a school and I found that the indoor air quality was often as terrible as the outdoor air, and sometimes it was even worse. You can see in this picture that the school had a dome and inside was a gym that was pumped with purified air. These were extreme levels required for such an extreme environment. I used these air quality monitors called laser eggs to investigate what changes could be made to improve the school's air quality. These have been incredibly helpful in understanding the effect of interventions and causes for poor air quality in the home, such as frying and incense burning, and I even have them now. I use them all the time. I found that when I moved to the Swiss Alps that my vision from living in Beijing had deteriorated and that I felt much healthier in a cleaner air environment. This should be the case for everyone around the world, but it isn't. And other health problems such as asthma and hay fever may be attributed to poor indoor air quality, as well as long-term illnesses such as strokes, heart disease and lung disease. We spend over 90% of our time indoors in the West, where life is like being inside this closed bottle. The MMI project is to measure the shape of this graph, where for a given composition, shape and density, what is the charge state distribution of different sized particles? And knowing this charge distribution may help to reduce generation of pollution and to improve filtration both in industry and in the home. And to do this, I'm going to be using a fairly new piece of apparatus called the Aerodynamic Aerosol Classifier, or the AAC, which is developed by combustion. This separates particles by centrifuge and keeps their original charge. Most other classifiers put a charge onto particles, which makes it impossible to measure their inherent charge. And you can see that the output particles here have the same size but different charges. I hope with the investigation that awareness of indoor air quality will be much better understood and that the quality of life of many around the world will be improved.